Okay, so this is for more information about the AC. If you go to the college, university, then we will go to more detail, okay? And will be no question in the test for this handout. Okay, so last time we already talking about a complex number. Okay, that means they get the form C equal A plus JB, where A and B, that's a real number. However, J equal square root of minus 1. Okay, that imaginary number. The number A equal a real part, okay, of C, and B equal imaginary, okay? J is used to denote the imaginary component rather than I. I want to using J, okay? Geometry. Now you can see on this coordinate here, that's the real part. And that will be for the J. Go up, positive J. Going down, negative J. So basically you understand a J means rotate 90 degrees. That means 0 right here. This is a 90 degree. So that will be rotate this way, okay? So you get the first J here, 90 degrees. Now, if you rotate another 90 degrees, what do you think you get? If you rotate another 90 degrees, what you get here?
Negative.
-6.
Ah. That one, that means you get J times J. J times J equal what? Hey. That's why I'm telling you one thing. You want to be learning, no matter what you want to learn. You must be reading over and over. Okay? So now my question is, this is a 90 degree. Okay? Okay, I get a question. How can you guys register for next class? I said after next week. We'll be doing it. Okay, now, again, J means rotate 90 degrees. So in here, 0. You go up here 90 degrees. That you get a J. And now if you rotate another one more, J, what you suppose you get here?
0.
Come on. J times J equal what?
-1.
-1.
Minus 1. Minus 1 just telling you they will be a real, right? Minus 1 means the real. So basically they're telling you right here, 0. to the right, you get a positive real number. Go to the left, negative real number. And now you rotate another 90 degrees. Y times Y times Y. Y times Y, you get minus 1. Times Y, you get minus Y. So that's why you can see going up, positive Y, going down, negative Y. And now it rotates another 90 degrees here. Y times Y times Y times Y. You go back to 1, real again. Okay? So, this is a rectangular form. Okay? Complex number in a rectangular form. Okay? And then also, another form you must know that we're talking about polar. Okay? The polar form that will be displayed C equal 10 with the angle 53.133. Okay, so basically that is a C right here. This is the angle right here. Okay, so in order to calculate the value of C, you're using this formula. C equals square root A squared plus B squared. And the fair angle here, that will be a 10 minus of B divided to A. So,
Mr. Pham,
yeah, go ahead.
If your A, is the A always on the bottom? In other words, the A is always like on the x-axis,
Right.
And the B is on the y-axis?
Right.
Okay, thank you.
A will be a real.
Okay, thank you.
Okay, so basically, in order to using this complex number, then you have to understand you get a complex number display in the rectangular. And also they will be using the polar. Okay. Last time we already go through this example here. Like they want to know a C here. Okay. So they want to know C in the rectangular and C in the polar. And this is the solution to what we already done for you. Only thing you must to read it again. Okay? And that's the same thing. Now, and also we already showed you Z square equals square root minus 1 times square root minus 1. You get minus 1. Z power 3. Z square times Z. You might get minus Z. Z4 is 1. Minus Z times Z. You get minus Z square. And that's what you get a 1. Okay? 1 over Z equals minus Z. Okay, this one we already done. Now, only thing to make sure you understand. If you want to add it in a complex or subtraction, you better using rectangular form. However, if you want to multiply or divide it using the polar. So now you get a times B, then they get A times B, and the angle will be theta of A plus theta of B. And if A divides to B, you will be get A divide B, and the angle will be theta of A minus theta of B. This is the formula, okay, in order to do a multiply or divide in the polar. And also last time, we already given you example, and we already saw this example for you ready. Same thing here. Now, this is the pocket for today. Now you get the RC in serial. So I'm talking about what we already done. Okay. Third, talking about what we already done before. They calculate the total impedance. So you know the formula? How to calculate the total impedance for this RC series.
I believe square root of XC square plus R1 square.
Is it square root? Right?
Yeah.
Now, how do we calculate the current?
VRMS divided by ZT, total impedance.
V total, right?
Yes.
Y,
ZT.
E total. Okay? How do we calculate the voltage VR?
IT.
IT. Right?
Yes.
Yes.
VC.
IT times X sub C.
And the angle.
Tan inverse. XC over R.
Right?
Right.
That's what we already done. Now, the question on this number 5. We calculate the phase angle between VT and IT. And you can get the calculation. In this circuitry, you understand you get a VR, IR in phase. They have a no phase different, right? And you get the VC and IC. What happened? Okay, you can see VR, IR in phase. How about IC? Okay, using VC, VCIC. Okay, what happened to VC and IC?
90-degree phase
90 degree.
difference.
Yeah.
I understand 90-degree difference. However, you have to get a little more detail.
Current lead to voltage.
I see. Lead VC 90 degrees. Correct?
Correct.
Yes.
Now, only the one they not in phase and they not 90-degree different. That's what the VT and the IT. So that's why you calculated 10 minus 1 minus HC over R. But the question is it a VT leading or IT leading? That means VT leading IT or IT leading VT or VT lagging. How do we know?
I believe IT is leading VT.
Don't guess.
And Mr. Pham, I thought in the past classes, I thought you said when you got a capacitor, the current leads the voltage.
For the capacitor, IC lead VC, okay, 90. However, VT and IT is not a formula for you. They just given to you the angle, but they're not telling you which one is leading or lagging.
So we can do the calculation using this formula.
How do we do the formula?
Pardon?
How do we get the formula? What formula?
You already wrote it.
You already get the angle.
IT lead BT in and theta.
I given you example. Minus 53 degrees. For example, not for this problem. But that is not telling you which one will be leading.
So should we go for a polar or rectangular coordinate, you mean to say?
No. That's
Okay.
my understanding. And you have to go into a little more detail, okay? You can see if you want to say you draw VR, now we'll see. If you draw that, will be VR. Where is VC?
VC going down.
Going down. Okay, and now you can get the figure right now. That is VR. And that is VC. And that is V total. Okay. Okay, so basically, IR will be the same IC, right?
Yeah.
IR, same thing. IC, same thing. I total. You see that? Only one correct.
Yep.
Okay. So that will be
That's a C, Mr. Pam, or E? A C or E?
C. IR, IC, IT, that's the same. Okay. And basically, we are here. Will be in phase
with the
with IC, right?
yeah.
So that will be telling you IC will be leading VT. 53 degrees. Now, I try to solve it. It's the same problem, but using complex number. Okay? So, in order to using the complex number, first thing, HC, you must be changed to minus J. Edit. Okay? The thing is we already know. HL, you get the positive J. HC, you get the negative. HL, HC all the time, opposite. One going up, the other going down. We already know. Okay? In the theory, this is HL, and this will be HC. Okay? So, in order to solve it using complex number, change HC to J minus J. Okay? So now, you go ahead and calculate for me Z total. Who can do it? Z total equal what?
I think so it's 100.
You get a real right here. Just add them up.
160.
Right?
So the formula in the C form of complex number would be 60 minus J80, correct?
All right. But then you're going to calculate the total impedance, just adding up. However, we already recommend to you when you're adding subtraction using the rectangular. So that's why 60 minus J80.
Mr. Pham, why 100 is not correct?
What do you mean 100?
So if we want to find out ZT, we can use the formula x square plus r square in the square root.
You mean we're using the square root of a square plus x
Yeah.
square?
Yeah.
No, we're not using that.
No, my question, how we will come to know that we need to use this formula or that formula?
No, either way you want to do. This is another way to
Okay.
solve it for the AC circuit.
So this total impedance is in a rectangular form, am I right?
You want for this using complex number.
Just a
If you
complex
want to
number.
calculate the total impedance, just add them up. However, what I'm saying is, IC must be changed to my not J80. That's just a formula. Then you can add them up 60, that's a real, minus J80.
Hey, Mr. Pham, I don't know if this is what he was talking about or not, but when you square 60 and you add it to a 80 squared and then take the square root, you get 100.
Right, but right now I'm talking about, I'm not did like the way we did before. I try to teach you, we can using the complex number to solving for this circuitry.
So that shows that you are representing total impedance in a complex form.
Right, using complex number.
Okay, got it.
That means for people want to learn more, or you go to the college, university, they're using this way. Either way, you can solve the problem. But this time I try to give another way. That's what we're using, a complex number. Okay? So if you want to calculate the total impedance, add them up. However, make sure IC must be changed to minus J. HL must be changed to Z before you want to add it or subtraction. Okay, so now you get 60 minus J80.
And that's equal to the impedance.
That equal impedance. But they not yet telling you the value. Okay, so right now you in the rectangular. I want GT in the polar.
And 53 degrees.
You get 100 square root angle.
53.
Minus or
Negative 53.1.
get that?
Right. You take negative 80 divided by 60, then you do arctan and you get the 53.1.
Okay.
So the answer is 100, the magnitude is 100, and the angle is negative 53.1.
Exactly. So GT, you know that you'll be 100 ohm. Okay.
Okay.
Now, if I do calculate the IT, VT, okay,
One.
VT is 100. However, they're not giving you angle. They will be 0 degree.
So reference.
Divide 100 angle minus 53 1. Tell me equal what?
1.
1.
Angle 53.
53 positive.
So you bring the angle to the top and make it positive, right?
That's the formula I just gave it to you.
Denominator, when it is in denominator, you subtract, but still it is negative, so you
Yeah.
mention it.
Yeah, yeah.
Okay. Okay, now in here, if you're looking into current I total, angle will be 53.1 degree. That means positive. That will be telling you IT leading VT 53.1 degree. You don't have to do anything. Okay? And if you want to calculate the VR, okay, VR will be IT time R. IT. You understand multiply, then you will be using the polar. So that's why you can get 1 angle. Okay. R will be 60 angle 0. Now, what they given to you? 1 times 60, right? 60 angle
53.
53.1
degree. Okay?
So fam, can I just ask a question on that?
Just a minute.
Okay.
VR equal 64. Okay. Now you can see VR get a 6 angle will be 53.1. And I total also 53.1. So that's why IRVR will be same phase. Okay, now question. What?
On that, okay, so you said 1 times 60 is 60, and then for the angle, what did you do? You subtract 53.0 from 53.1, just for example. Is that how you did it?
IT, right?
Yeah, IT times R.
Okay, so IT 100 divide 100 to get what?
Right.
Angle will be 0 minus 2 minus. Okay,
Plus
angle will be 0 minus 53. That's why you get 53,
Okay.
right?
Okay.
And the last one will be VC. VC will be equal I total time IC. I total will be 60, 53.1. How about IC?
I think I total is 1 to the angle of 53.1.
Oh,
1, not 60.
yeah, sorry. 1, right?
Yes.
Okay, thank you. How about IC?
Axis 80 negative 90, angle negative 90.
80. Right?
Yeah, an angle negative 90.
Yeah, you get better.
Yeah.
Okay? So they will be 80. What the angle?
They're different.
Minus what?
53.1 minus 90, that is minus 47, 37.
90
56.9.
minus 53.1. 36.9.
That's correct.
Right.
And the value. You know, normally I like this way to solving the problem. I don't have to thinking anything. Only thing get along with the rectangular and the polar. So, any question?
Mr. Pham, the last thing you wrote is 80 volts. VC is equal to 80 volts. And you calculated 80 and then angle like negative 36.9. What's the difference? Is it, are you writing a magnitude only, 80 volts?
What do you mean, what a difference?
The last step you wrote.
Yeah, minus 36.9.
Both are VC, am I right?
Yeah, that's a voltage VC.
So what is the difference here on the left-hand side? VC is 80 angle negative 36.9 and VC is equal to 80 volts. Both are VC. What's the difference?
No, that's a 80 volt telling you the magnitude.
Oh, I got it. Magnitude it is. Okay, got it. Thank you.
That's what we already telling you. Where is it? That's the magnitude here. You see that?
Yeah, I got it.
Okay. And also phase angle. Okay, now you do for me.
Mr. Pham,
Yes, sir.
if you go back just a little, that last problem. So VC is, the angle is minus 36.9. So that means the voltage is lagging behind the current, right? Is that correct?
Right.
And then when we try to work out the phase angle between VT and VR,
Then you're looking on which one?
number 5.
Number 5. 80 in magnitude, right? Value. This is the value of VC.
Right.
This is just a phase angle.
That's in relation to IT.
Now, I think that should be relation maybe to VT. IT supposed to be minus 90 degrees.
Right. Oh yeah, it's minus 90. So this is VC lags VT, the total, by minus 36.9 degrees.
Right.
Okay. And then VT, the voltage total lag behind IT by 51.1 degrees.
53.1.
Okay. All right. Thank you.
The thing is when you're using the complex number, automatically they're giving you the phase. Okay, now do it for me on that one. Try to see who can get through it. It's just a very, very basic for you want to learn more, like you go to the college or university. That will be help a lot. If you can understand whatever I teach you in this program, keep going. Next few more years, you can be an engineer. Only thing I want, give me the answer.
The first one is 30 plus 40J.
What the value?
30 plus 40J.
Okay,
30 plus
And
G
that's
40.
30, right?
Hmm.
Not
40J.
40, yeah.
14 must be changed to yeah. And now you can telling me the value and the phase.
50, angle 53.1.
Okay.
Yeah.
What the amplitude?
50.
50, right?
50.
Yeah.
Five.
Angle 50. Is it 50 what?
53.1.
53.1.
Okay, 53.
3.1.
Okay. IT.
Amplitude is 1.
Minus 53.1.
Okay. ITVT, which one leading?
I T and
B leading.
Which one leading?
VT is leading?
Exactly.
VT.
VT. Lead. IT. 53.1 degree. When you see IT is positive, IT leading. They negative, they lagging. Then you can calculate the VR. Okay, IT times R, VL, IT times HL. Okay, so basically you get one
1.
angle
Negative 53.
minus 53.1 time R will be 30.
At 0 degrees.
0. Okay, so you get 30 angle. Okay, is it 36, right? We already calculated before.
That'll be 1.
36.9.
36.9, yeah.
So you see that's so easy.
After 27 years, it's easy.
So, Mr. Smith, are you here since last 27 years?
No, that's Mr. Pham.
Oh,
I mean 35 years.
Okay, 35 years. I cheated you out of 8 years.
But this is the first summer class. I believe I did very good job for trending AC compare in the past.
Well, this is the COVID season, so that makes a difference too.
The thing is when we're talking in the Zoom, that's why you can learn more.
Everybody's forced to communicate.
Only thing is if you not understand, confusing anything, just bring it up. We just learn it. More people talking, I know who. So that's why normally when you apply the job, the company will be sent to me a letter for recommendation. Okay, recommendation. I have to know who. in order I can let them know. Most of the students, like before they be in the program with me almost 1 year, guarantee with you I know who will be doing a good job or who okay, or someone I have no idea. Okay, up to this point, any question? Okay, I think that one. If you can do that one, you okay. However, what I telling you, HL change to yeah,
J4.
40. Okay, so normally they want IR. And they want IL. Okay, you do for me. IR will be 12,
12. So
0,
divide
divide,
30. 0.
okay?
Okay. $40 with 90.
Angle 90 degree.
Right?
Right.
Yes. 0.3.
And 3,
Angle is, yeah, I think so.
Right.
0.3.
and 3.
0.3. Angle is negative 90.
Yeah.
Perfect.
Yeah.
Yeah. Okay. I total.
You add both the angles, both the currents.
Okay.
IR plus IL.
IR plus IL. However, when you plot, you have to using rectangular, right? I total equal IR. IR will be 30. Now, 0.4.
0.4.
Okay, IL. IL
0.3 G.
what?
0.3.
G 0.3.
No. You have to converting rectangular.
Okay.
Okay, I got it.
Sorry. To
So
That's right.
yes.
Minus 90 means minus Z. That will be telling you. You have to convert in 0.4 minus J03 to the polar.
.5.
If you want to get to the polar, then you have to get square root right? 0.4 square lot 0.3 square.
square
0.12.
0.5.
0.1,
0.1.
0.5.
I don't think so. It's 0.5.
I think it's 0.12 if I'm right.
Yeah, because square root of 0.4 is 1.
Okay, let's see.
0.5.
0.4 square equal
Yeah,
lot
0.2.
0.3 square
Yeah, it's 0.5.
equal, take a square root 0.5 angle
0.4 square plus 0.3 square equal. Oh yeah, okay. 0.5. 53. Negative 53.
Negative 50.
What you get?
Minus 90.
Negative 33 point.
No, I don't think so. You will get negative 53 because you are going to do tan inverse 0.3 divided by 0.4. And I think so is negative 90.
Why not?
36.8.
Is that right?
Yeah. Yeah.
-1. 36, yeah.
If you calculate the Z total, okay,
B
V
total,
total,
E total.
V total is 12.
$24.
You get 24
Mm-hmm.
angle.
$36.8 positive.
Okay. Angle. You understand it 30 minus 36.8. However, VTIT, which one is leading?
Voltage lead current by 36.8.
Correct.
Mr. Pham, I got a little question. In the formula where you got IT equals IR plus IL, and then you said 0.4 minus J 0.3. If it's an inductor, how come we got minus J?
The thing is, IT equal IR plus IL. Right here. You calculate by 0.3 minus 90 degrees. If you change it into the polar, that means minus J03.
I think I'm a little confused only because I thought the inductor was always plus.
Now, inductor IL will be plus. However, IL will be minus.
Okay. So then IC, if we had an IC, the IC would be plus.
Exactly.
So they for the current, they're the opposite.
Right.
Okay, thank you.
I'm not working on this one. Now try to do this one. In order to do it, then XL to J then IC to minus J 60. You understand that you cannot solving for both C and L. In the past, we already did it. You have to say IC, IL, which one higher?
So XC is higher, So it's 60 minus 20, which is 40.
Right.
So then it'd be minus J 40.
That means you can get this circuitry. So that still be 30. However, that will be
40.
J, right?
Mhm. So for rectangular, you would have 30 minus J 40.
Now, but the thing is we don't want. We
Negative.
don't want to do that,
Negative.
okay? You do like normal. You want GT will be equal 30 minus 60 plus right?
Oh, you want to do it like that?
We don't care about circuitry inductive capacity. Just add them up. So finally, J equal 30.
Minus J
Minus.
40.
Okay?
Yeah.
Then
Okay.
you convert into the polar. That means you get square root 30 square plus 40 square. Is it 5?
50.
50.
50.
Angle.
Minus 53.
That means minus 40.
53.1.
Is that negative?
Negative.
You get that?
Yes.
Yeah.
Then you can calculate the IT. $120. $2.4, right?
Right. 2.4.
So ITVT, which one leading?
VT is leading IT.
IT leading.
IT?
Yeah, when you calculate the IT, the
Oh, yeah,
phase
yeah.
angle.
Yeah, it's positive. Yeah.
Positive.
Positive. Yeah.
Okay. And the red will be the same. Okay. VR and IT R. VC IT time IC VL Okay. That one IT will be 2.4. IT 60. Not yet. Okay, so tomorrow will be given you the review tab. And on the tab for the technician, not much calculation. We'll be asking for understanding. And we will be run the review tab after you're done. And we'll be go to try to give you the answer. Okay? Try to explain to you how come we get that answer. And you need to review that for the final. Guarantee you get C. Okay?
Okay.
Now, any question to me?
So Mr. Pham, for this one, the phi L, that's going to be 143.1 is the angle, right?
Right.
Okay.
Okay? So good night. See you tomorrow.
Good night.
See you, nice.